Hi guys, forgive the noise. I'm kind of doing this in the drop-in center because I have the time. But I wanted to go over number 5. Number 5 is H2 is produced by the reaction of 118.5 milliliters of a 0.8775 molar solution of H3PO4 according to the following equation. 2Cr plus 2H3PO4 reacts to 3H2 plus 2CrPO4. So it asks us to outline the steps necessary to determine the number of moles and the mass of H2. Then it asks us to perform the calculations outlined. So what we're given is we're given the amount of volume. I'm going to write given, actually. Given our volume in milliliters, and we're given the molarity of H3. I'm going to put capital L of H3PO4. According to this equation, we're trying to find the number of moles and the mass of H2. So we know that the volume, the milliliters, are actually of this substance that has a molarity of this. And so what I would initially start with is our volume. So first we're going to take the volume, and I would convert it to liters. So we know that 1,000 milliliters equals 1 liter, so we're going to move the decimal point 3 places, and I'm just going to put this at the bottom, so then we don't have to worry about moving our outlined steps, but I'm going to write 1185, so 0.1185 liters, and I'm going to put H3PO4 because that's what it is. Our substance, that's what our substance is as of right now. Next, step 2, we're going to take the molarity and find moles of H3PO4. So our molarity is 0.8775. I'm going to put 0.8. I keep messing up the numbers, but 8775. And we're going to say that's moles because we know molarity, big M, equals moles of a substance over liters of a substance. So we know this is how many moles of H3PO4 are in 1 liter of H3PO4. More often than not, you're just going to leave the liters by itself because we know that this is how many liters of the substance we have, and then this is how many liters are in the molarity. We know that it's always 1 liter per however many moles. From that, we are going to find the molar ratio and use it to find H2. We're going to find H2 moles. I'm going to put that in parentheses. we know our molar ratio is for every 2 moles of H3PO4, we're going to get 3 moles of H2. And so from that, we're going to use our molar ratio, which is that 2 moles of H3PO4 to 3 moles of H2. And so once we find that, we technically found the moles, but we want to continue on to get the mass. So for our 4th step, we are going to find the molar mass. Take the molar mass of H2 to find grams H2. So from that, we know that in 1 mole of H2, and H by itself is 1.008, so we know it's going to be 2.016 grams of H2, because we multiply that by 2. And that's how we're going to find our grams. Our mass, which our mass is usually in grams. So I'm going to get out my handy dandy calculator and find how many moles of H2 we have. That is going to be 0.1185 times 0.8775 times 3 divided by 2. And we should get moles of H2 equals 0.1. We have, it looks like 4 significant figures. I'm going to say that it's 3 significant figures based off of the original that we had. So I'm going to say it's 1, 5, 6. And then our grams, we just multiply that number by 2.016. And we should get 0.314 grams H2. And so from there, we have our answer in moles, and we have our answer in grams.